Hey guys, welcome back to Programming in Objective-C. It's Yari Dareglia of Jump Zero. In this lesson I show you one of the most important patterns used in Objective-C, the delegate pattern, and then we talk about protocols, a way to define precise interfaces. Speaking about object-oriented programming, it's important to find a solid pattern to create your classes. The delegation is a way to maintain the logic of your class as simple as possible, giving an helper object the responsibility to execute some tasks. This object is called delegate. With this pattern, you are able to define the main behavior of your class and demand the operational tasks to external objects. So for any given object, we define the tasks, but the execution of those tasks are delegated to other objects. It's as simple as that. Let's create a real example and code it in Objective-C to better understand this pattern. We can take the class spaceship. This class has one main function, fly, and has a property of type pilot. The pilot has the ability to travel, and to do this operation, when possible, it uses a vehicle as delegate, in this example a spaceship, but it could be any vehicle. So let's create this code from scratch. Create a new command line tool project and follow me. At first we create the pilot class as NSObject subclass. In its interface we add the delegate, so add property weak id delegate. It's a weak reference because, as we'll see, the pilot will be directly referenced by the spaceship as its property, and so we want to avoid a retain cycle. Then we create its unique function travel. The prototype is extremely simple, it doesn't return any value and it doesn't take any argument. Let's see the implementation. Open the file pilot.m and synthesize the delegate. And then move on to the implementation of travel. First, we check if our delegate is able to respond to a message called fly with response to selector. Then, if it can do that, we choose to use the delegate to fly with the flight selector. If the delegate cannot fly, we then just go by foot. So, as you can see, we don't know anything about how the delegate will fly. The pilot has delegated this operation and it is not interested in it. The important thing is that the delegate will be able to do that. We don't want to know how. Now, let's implement the spaceship. Create a new class, subclass of NSObject, and call it spaceship. In the interface, import the pilot header and add the property pilot. This time it's strong, because we want to be sure to retain the pilot since the spaceship exists. Now we add two functions, obviously the fly function, and then we want to create a better initializer for this class, that take the pilot as parameter. Let's move to the implementation file, synthesize the pilot, and implement the two methods. The fly method is really simple. It's just write spaceship has taken off in the console. Now let's implement the init method. This is the designated initializer, so we call the super init from here. If the base object is ready, we can valorize the pilot property with the received pilot. Now we set the pilot delegate with self, so the spaceship will be the delegate for the pilot. And then we return the object. Now, in the main.m file, let's instantiate a pilot and a spaceship. We first create the pilot with the standard alloc init toStage pattern. And then we create the spaceship using the custom initializer and giving the just created pilot as argument. Then we can ask the pilot to travel, and as you can see compiling, it will use the spaceship to perform this operation. Okay, this is a fast example of delegation. We can create other flying classes like helicopter and airplane and assign them as delegate of pilot without changing a row in the pilot class. This is a good design choice, but we can go one step further, adding some information about the delegate needed by pilot. Every class we want as delegate for pilot to be perfectly integrated with it must implement the method fly. So it will be useful to create a set of rules to be sure that the delegate object responds to the pilot needs. To achieve this task, we can use a construct called protocol. Let's see what a protocol is. Through a protocol, we define an abstract interface that a class must implement to conform to that protocol. This means that with a protocol, we define an interface but without an implementation. If you come from Java or PHP, you might recall something similar with interfaces, and if you come from C++ with abstract classes. A protocol definition follows a straightforward syntax. We use @protocol to open the definition, and then we choose a name for the protocol. Then we can define the prototype of methods that should be implemented to conform to that protocol. And we can also define optional methods that you might implement. Whenever we want to define a class which implements this protocol, we must slightly modify its interface this way, adding the protocol after the superclass definition. And in the implementation of the class, we have obviously to implement at least its required methods. Now we can define a property with some more information. So for example, we can define a specific delegate by adding the protocol information. This way we have just added a requirement to the delegate. It's still a generic ID object, but it must implement a protocol. Let's move on with the previous example and create a protocol for the pilot delegate. Add the protocol definition just before the pilot interface. This is a simple protocol. We only need the delegate to respond to the method fly. Through the NS object, you are also sure that the class that implements your protocol also implements the NS object protocol. This is a standard behavior, so just take it as is. And now, let's modify the delegate property adding a protocol information. Now, if we compile, we get a warning message saying that we have assigned an incompatible type to the pilot delegate. So let's open the spaceship class and add the needed information to the interface. Okay, we've done. So with delegate and protocol, you can achieve a really good design for your classes and be generic but at the same time really precise. This is the end of the lesson. See you next time with categories and class extensions. Thanks for watching.